Hello guys, welcome back to STEM Trainers. In the previous video, we have seen velocity time graph and we have seen the two most important things, that is gradient area and how we can find use area to find displacement and distance. Okay, so today we are going to see displacement time graphs. So I have taken some graphs, some straight lines and some curved graph. So there can be many relations between displacement and time. So there can be many curves, but I have just taken few which are most important and mostly questions come on these. Okay, so first you can see, as you can see, this is my displacement is on y-axis and time is on x-axis. Again, the same argument I have given in velocity time graphs. I can interchange them also. Of course, you can, right? It's a graph. You can interchange the x and y and you can draw a different graph. But it's most useful when displacement is on y-axis and time is on x-axis. Okay, so in the first graph, you can see my displacement is constant with time. Displacement is constant. So what does this mean? Particle is not moving. So particle or object, whatever it is, let's say object is at rest. It's not moving at all. Okay, B part I can say, with as time increases, my displacement is increasing, right? So displacement is increasing. In the third part, you can see as time increases, my displacement is decreasing, correct? Graph is going down. In the fourth part, we can say as time increases, graph is going up. It means my displacement is going up. That is, displacement is increasing. Okay, that's it. That's the first observation that we can see. Nothing else. Okay. Next thing, gradient of displacement time graph. Now, gradient of displacement time graph gives us velocity. Okay. So in the first graph, as my gradient is 0, so I can say my velocity is also 0. I think it's simple. Everyone can understand. The gradient is positive. And obviously it's a straight line. So it's straight line, at every point you have same gradient. So we can say my velocity is constant and positive also, because gradient is positive. So let me just write here. So my velocity is constant and positive also, because gradient is positive. What's happening in C? As you can see, my gradient of this line is negative. So velocity is negative, but constant. It's not changing because the gradient of this graph is not changing. What's happening in D? Mostly they will ask you questions on A, B, C, but let's just discuss D also. In case. So as we discussed in velocity time graphs also, if you take a tangent here, you take another tangent here. Why I am taking tangent? In case some student is not understanding. See, the gradient of tangent is basically the gradient of curve. So that's why I'm making some tangents. Now you can see gradient at point A is less than my gradient at point B. So I can say that my velocity is increasing. So velocity at A is less than velocity at B, because gradient at B is greater than gradient at A. So I can say here, as we are moving on this curve, as time is increasing, my velocity is also increasing. So that's a thing that we can say. That is, we can say particle is accelerating. You can say that also. Okay. So I hope you guys understand this. Area of displacement. So it gives basically nothing that is of use in this curriculum. Nothing of use in this curriculum. So we don't have to find area. So basically area comes into picture only in velocity time graph. So that's why velocity time graphs questions are more as compared to displacement time graph. Okay, let's try some of the questions. And okay, yeah, couple of things. First thing is average velocity. I hope everyone understand average velocity is total displacement over total time, and average speed is total distance traveled over total time. So velocity has direct relation to displacement and speed has direct relation to distance. I hope everyone understands this. Okay, next one. Uh, Question is this: a ring is moving up and down on a vertical pole. Okay, so up and down, a ring is moving. Okay, displacement of the ring above a mark on a pole is modeled by the displacement time graph. Okay, so some graph is given of the ring moving up and down on a vertical pole. Okay, distance is in meter, displacement is in meter, time is in seconds. Okay, I always check the units because it's always important to check the units. Okay, first is calculate the velocity of the ring in the interval 0 to 2 and then 2 to 3.5. Okay, 0 to 2. First thing, velocity in displacement time graph is nothing but gradient. So from 0, this is 0, 0 to 2 seconds, my graph is a straight line. And for straight line, there is only one gradient. So it means velocity is constant. So we can say from 0 to 2, my velocity is constant. And for finding the value of the velocity, I will have to find the gradient. So what is this value? This is 2, right? I am going to find rise over run. So this is 2 and this is 5 and 1. So this will be 4. I hope everyone understands this. So this is 2, this is 4. So for the A part, let's do it here. For A part, that is time from 0 to 2, my velocity is going to be 4 over 2 meter per second. That is nothing but 2 meter per second. So that is my velocity. Now for time equal to 2 to 3.5. Okay, so from this, let's name this as A point. Let's take this point as B point. Can I find the coordinates of A and B? Yes, of course. This is 2, this is 5. So this is 2, 5. What is B? X coordinate is 3.5. What is my Y coordinate? That is given as minus 2.5. Okay. So as we know the 2 points on a straight line, so obviously we can find the gradient also. So let's do that. So in B part, sorry, for time 2 to 3.5, my velocity is going to be the gradient of this. So gradient is y2 minus y1. That is 5 minus of minus 2.5 over x2 minus x1. That is 2 minus 3.5, which is coming out to be 7.5 divided by minus 1.5. I think this is 5. So minus 5 meter per second. Negative. Yep, of course it's negative. We have done this. This line has negative gradients. Obviously velocity will be negative. So that's why the answer is negative. So velocity is minus 5. Okay. Next. Sketch velocity time graph for the motion of the ring during 4 seconds. So first 2 seconds we know its velocity is 2 meter per second. For the next 2 to 3.5 we know its velocity is minus 5 meter per second. What's happening from 3.5 to 4? This is the graph. So this is a straight line parallel to t-axis. So gradient is 0. Gradient 0 means velocity is 0. So let's draw this now. So for 3.5 to 4, what's happening is my velocity is 0 because my gradient is 0. So let's draw this graph. It's a very easy graph, I guess. So this is 0. Let's say this is 2. Let's say this is 3.5. And let's say this is my 4 value. So this is my time. This is my velocity. So 2 meters per second. So this is 2. be like this. And then what's happening is, after that, my velocity is minus 5. So 2 to 3.5, my velocity is minus 5. And then from 3.5 to 4, my velocity is 0. So this is my graph. This value is 2, this value is minus 5, and this is 0. So this should be the velocity time graph. Okay. Now, if they ask what's the total distance covered by the ring, so what you can do is, this is velocity time graph, just find the area. And when you find the area, you will get to know the distance covered also. You can find displacement also, as we discussed. Anyways, that's not the question they are asking. Next is, state the direction of motion of the ring when time t is equal to 1. So this is time t equal to 1 somewhere here, right? 1 second. Obviously, velocity is positive. So we can say the particle or the motion of the ring is upwards, right? Because velocity is positive. What's happening at 2.75? 2.75 is somewhere here. Now, this velocity is negative. So we can say particle is moving downwards. 3.25 is somewhere here. So again, particle velocity is negative. So we can say it is moving downwards. That's it. That's it. All they are asking. Further, anyways, so I hope everyone understands this. Thanks for watching, STEM Trainers.